So I'm Erik. So I'm responsible of development of products within SAP, and we are developing predictive and BI software in my organization. I'm part of a big company, so we have to have a disclaimer on these kind of things, in our presentations. Sorry. Okay. And then after that, I will talk to you about how to integrate machine learning. I will avoid the term AI as much as I can. Machine learning within enterprise applications. And the first thing that you have to remember is that when we talk to the CIOs of the world, the CFOs of the world, or whatever, we are still in the process of evangelizing them what machine learning can bring to their area of interest. So the first thing that we need to do is to sell to basically the enterprise stakeholders, all these notions about machine learning. And the thing that they know that are the closest things about when we talk about predictive analytics, machine learning, data science, is the term analytics, which covers business intelligence, OLAP, agile visualization, and all these kind of things. So this is why I'm using this curve. So normally this slide is decomposed in 3 slides or whatever, but we have only 20 minutes, so we're going to rush into this. So this is the classical stuff where you can see the maturity of analytical capabilities on the horizontal axis, and on the vertical axis is productivity, mainly dollars, okay, or euros, or whatever you mean. And usually this is presented as, the kind of continuum from the analytics world to the predictive machine learning world and everything like that. As you can see, the way that I'm presenting that is a little bit different, because I say, well, careful here. On the left-hand side of the thing, you have one beast. On the right-hand side of this diagram, you have another beast. Why? Because everything that is done on the left-hand side, that the things that you know, Mr. CIO, Mr. CFO, Mr. CMO, and whatever, is for humans to make decisions. And these have some impacts. The fact that, for example, the data must be aggregated for visualization, because after 5 dimensions, humans are blind and whatever, so you need to aggregate that in order to present that in charts into things that can be understood by humans in order for them to make decisions. The other thing is that the time is instantaneous. That means that usually time is another dimension that you are manipulating, and that's it. I mean, there is not really fine-grained information about the fact that some characteristics of some of your customers, for example, have room from this to this, from Q4 to Q1, and all these kind of things. And since we are talking about human decisions at the end of the day, when we talk about integration within enterprise applications, we talk about UI integrations. So that means you want to see the charts, again, in order for the humans in operations to make their own decisions. And when you switch, and this is all everything on the left-hand side, when you switch to the right-hand side of this graph, then you talk about a completely different world, because everything here is not for humans to make decisions, that's for the machines to make decisions. I mean, if you do not want to have responsibility problems or whatever, you can have the machines just propose the decisions and the human click on OK. But at the end of the day, that's what we are looking for here. When you look about the data access, data is denormalized, flattened, fine-grained, okay? We have, when you do, for example, when you apply machine learning, predictive analytics into the customer lifecycle, it's not uncommon to describe all your customers by 15,000 attributes. When you take a snapshot of the customers as they were 3 months ago, for example, taking into account all the behavioral information that you can gather from them, you can deal with a lot of information. And of course, that's a snapshot of those customers at that point of time, which means that the time information is very important. You need to create the analytical data set in order to create your predictive models, again, as things they were 3 months ago, associated with the fact that, for example, your customers have bought this product or not into the last 3 months. And then you can train your predictive models, and then after that you can apply the predictive models on the snapshots of the active customers today as they are today again. So the notion of time in the data preparation is something which is very important. And so also, because I said that machines are here in order to make decisions, when we talk about integration within business processes, we're talking about a process integration. And at the end of the day, sometimes I'm saying, well, the best data mining UI or data science UI is no UI at all. Okay? Everything should be done transparently by the machines at the end of the day. And the final point, which is also very important for the CIOs, the CFOs, and whatever, it's that here on the left-hand side, people just, or the systems don't just read the data. Here, when you begin to use predictive analytics and machine learning, you will generate a lot of data. You will generate decisions. You will generate probabilities. Like, for example, the million of probabilities that each of your million customers will buy each of your offers contacted through each of your channels at different time horizons. And this is not, so this is millions of data points that you will create using those kind of things. And at the end of the day also, it's not only probabilities, it could be reason codes. So you can associate to each of the probability that you are generating the fact explaining the fact that this probability is high or low. So not only you need to read data, but you need to produce data. And when you are in an enterprise environment, that means access rights and a lot of things that are associated with that. So that's the thing. So another way of looking at that is that, oh yeah, well, sorry. Can I go back?
Yeah, you should.
Well, yes, okay, thanks. So this curve is usually originally a kind of linear curve and everything like that. What we've seen also in the last years is that people begin to use predictive analytics and machine learning techniques in the BI landscape, okay? And that's something that is called smart and augmented analytics. In other way, you can use mathematics in order to find the golden nuggets or the insights in order to present that to the users in order for them to make decisions. And the other thing that we've seen, and a lot of things that we have been talking about here, is around deep learning and these kind of things. Basically, those machine learning techniques have been used lately into unstructured data, and that means voice, image, text, natural language, and everything like that. And so that means that there is another spin-off of this curve, which is basically the human-machine interface. So where people are a lot talking about conversational AI and all these kind of things, and that's certainly something that is going into fruit. So I will not dive into all the technologies that you need for prescriptive. Basically, it's using the raw results of predictive, such as probabilities, estimates, forecasts, segments, classifications, all these kind of things. And then you mix that with business processes, with optimization techniques, rule-based systems, in order to use that in operations. And of course, at the end of the day, the ultimate grail of everything like that is to build autonomous systems. So another way of presenting that is, at the end of the day, you have analytics, which is powered by humans for humans. You have augmented smart analytics, which is powered by mathematics for humans. And then you have all the advanced analytics arena, which is powered by math for processes in order for machines to make operational tactical decisions. I don't think that we are yet at the level where machines will make strategic decisions. And then after that, you have the cognitive artificial intelligence, where it's powered by math, either to interact with humans or for autonomous systems. Underneath all that, you have zillions of technologies. So the good news is that in SAP, we are mastering most of those technologies, but underneath all that, you have zillions of technologies. And this is something that you need if you want to embed, ingrain all that within enterprise applications at the end of the day. So I will not dive into each of that. Hopefully you've taken the photo. Yeah. But the other thing that I'm using also is that I'm usually using this story, you know, the Inuits, you know, the guys living in North Alaska, Canada, and whatever, they have 8 different words for snow. In French, we have only 1 word for snow. In English too, I think, okay? And that's a little bit the same thing for machine learning. And that's a little bit this kind of things that I would like to go with you through. So the first thing is that that's a little bit like macroeconomics and microeconomics, okay? So the things that are dealing with the economics of the states, the systems and whatever, and the economics that are dealt with, let's say, with the enterprise and something like that. That's the same thing for machine learning. You have macro machine learning and micro machine learning. What is macro machine learning? It's usually predictive models, pre-trained as a service. At the end of the day, in order to do that, you need to have a huge databases. ECG or EKG interpretation can be one of them, for example. And what you want to do is to make sure that you have an easy access to these pre-trained models. But the drawback of that is that at the end of the day, how many of those systems do you need on the planet? How many image recognition systems do you need on the planet? How many translation systems do you need on the planet? Of course, how many autonomous vehicle systems do you need on the planet? It has been said that hundreds of teams are working now on those autonomous systems. My guess is that in 10 years from now, or perhaps in 5 years from now, there will be perhaps 20 teams, and in 10 years from now, there will be perhaps only 10 teams working on autonomous vehicle. Okay, because how many do you need? If you build one that are very efficient, you don't need that many. The second thing is macro machine learning, where here the main challenge is, well, you know, when you are building a churn model, for example, for a telco, so that means a system that is trying to predict which customers will leave you into the coming 6 months. Well, it is very likely that the system that you will train on the Orange data, for example, as a telecom provider, or Verizon or British Telecom will be the same. So what you need for those kind of systems is to have learning as a service. So it's not model as a service, it's really learning as a service. And here, of course, the key factor is automation. So that means that if you have automated systems that can train those systems, you're going to gain a lot of productivity. And here I'm completely aligned with the previous talks on the fact that precision is one aspect of the problem, but scalability is speed and scalability is the very key for that. So this is the thing that we're calling massive machine learning. And of course, if you want to ingrain things within enterprise applications, you need both things. And I will explain to you why a little bit after that. Then you have two operational contexts, okay? There is not that much of choice. You have algorithms, you have data, so you have two solutions. Either you bring machine learning to the data, or you bring data to the machine learning. If you know a third way, please, I would like to have a talk with you on that. But of course, so that means that most of the time you have to implement your algorithms for the first kind of things, which is really deeply embedded, okay, into the, I would say, enterprise application environment. Usually it's databases, so of course in SAP we have different type of databases. We have HANA, which is our in-memory database for translytics, so that means as well for transactional and for analytics workflows. We have also Vora, which is a scale-out kind of Hadoop Spark type of offer if you want. But here the main challenges is that if you deeply embed and want to use algorithms which are close to your data landscape, you certainly don't want to have 10 data scientists playing with the database that is used in operations. So basically, you will have to come up with something such as a sandboxing tendency in order to make sure that you can have a development environment and a deployment environment that are really intertwined, that is almost transparent to the user, but in order to make sure that you do not do a kind of attack the operational systems. The other thing is that, and one way of coping with that problem is to bring the data to the machine learning. Most of the cloud offers right now, they are running into that environment where basically you upload your data somewhere in the cloud where you can use your algorithms the way that they implemented, or even specific hardware such as GPUs and these kind of things. So here the challenges, that's the data transfer, the security, and all these kind of things. When you want to reintegrate back, for example, the things that have been generated in there into your enterprise software, which may not be in the cloud or in the same cloud at the end of the day. You have also different data families, so you have the structured data, with different challenges again. I mean, structured data, that means that, for example, when you connect to a SAP ERP, you will be in front of 40,000 tables, okay? And in those tables, you will have strings, currencies, numbers, integers, you will have symbols, you will have latitude, longitude, why not, all these kind of things. So here, the main problem that we have to face is how do I go from this environment, okay, with sometimes rich semantics, because people in BI have spent a lot of energy in order to build semantic layer on top of that, okay? And how will you go from this environment to, well, the snapshot of the customers as they were 3 months ago, and only the one that didn't buy my credit card, for example. So that's the challenge is really in the self-service data preparation. That's still an open question. We have some ideas in order to go there, but that's really the environment here. Then you have the streaming data, so mainly in IoT, with real-time feature engineering. So that goes from a lot of things are noise cancellation systems, because when you are going closer and closer to the sensors, there is a lot of noise in there. We've seen that in the ECG, for example. But so that means Kalman filtering, fast Fourier filtering, all these kind of things are very important. And also, I mean, if you talk about IoT, well, perhaps 80% of the use cases will be around predictive maintenance. And predictive maintenance, one of the problems is that, well, basically you want to predict failures, but in real world, usually you have a very few numbers of actual failures in the past. So that means that you need to use very, very robust techniques that are able to build robust solutions based on 10 failures, for example, that you've seen in the past. And that's a challenge. Or you use outlier detection systems on those kind of things. And then after that, there is the unstructured data. I mean, as a kind of provocation, I say unstructured data means very simple structure, because when you talk, for example, about an image, at the end of the day, that's 1,000 by 1,000 pixels, which are all simple numbers in the same range and everything like that, very homogeneous. So from a pure IT perspective, it's a very simple structure. Now, the complexity resides on the fact that there is a very, very strong interactions between those data points, those data elements, pixel to pixel. And this is why you need deep learning techniques in order to extract all those complex interactions between the pixels that sometimes are very close together, sometimes are not close together. So a lot of energy are spent now on natural language processing and chatbots on that. So that's a little bit the landscape. And when you want to integrate machine learning into enterprise applications, you need to cover all that. So the mission of SAP, it's of course, I would say, to enable a large organization, large enterprises with all their backbones in terms of software infrastructure. And in particular for us in machine learning, the vision, it's enterprise. It's intelligent enterprise at the end of the day. And here you can see that there are two aspects of that. The first aspect is really automate knowledge work, which is basically margin optimization, okay? You want to forecast the resource you want to forecast what you want to do as a business in order to optimize the resource. A lot of things can be automated on the knowledge worker type of things. So the domains in which, we have been very successful is, of course, customer lifecycle, but everybody knows how to do that right now. Then after that, the domain in which that we have seen lately is HR, so that means human resource. The same techniques that you can use in order to predict the fact that a customer will leave you into the coming 3 months. You can use that on your employees to predict the probability that they will leave you in the coming 6 months. The same thing that you are using for product recommendation, you can use that, for example, for training recommendation in order to boost, I would say, the employability of your employees and things like that. And also the latest thing that we've seen very likely is the CFOs. This is why I'm using this term very often. Finance is a very, very strong domain in which we can use predictive techniques. So that's the classical stuff, and then there is the do the impossible, which is not simply optimizing the margin on the current business process, but finding new business models, because you master machine learning and predictive analytics. So, for example, a travel concierge, okay, that's something that your flight is cancelled, you have something that automatically rebook you, change the hotels, do something, or eventually cancel everything because that's not going to be worth your time to go there. You have a lot of things in fashion retail where, for example, you go in front of a mirror and the systems will not only analyze the colors, but will be able to propose you things into the mirror, like, for example, a scarf or something like that goes with your dress. And then after that, they can even analyze the face in order to see your feelings about the fact that you are presenting that to them. All that can be done today. So our innovation system in SAP, it's Leonardo. So that means that Leonardo is 3 things. That's a methodology around design thinking and other things like that. That's a technology stack, so around the blockchain, IoT, analytics, machine learning, everything like that. And that's also accelerators, so pre-packaged around those kind of things. And what's important in Leonardo machine learning, I will not dive into all that, is that it's the persona that you are targeting. So everything should be done for the business users in order for them to use the tools that they are using on a day-to-day basis. So here I put Ariba, Hybris, Concur, S4HANA, Fieldglass, SuccessFactors, so that for your HR, for your procurement, for your Salesforce automation, for your finance, okay, that's the applications that those guys are using today. And we can power all those guys with, I would say, predictive and machine learning snippets into that. Then you need developer tools in order to make sure that the developers can use that. And then finally, you need data scientist tools in order for them to develop their predictive models. And all that must work into a coherent way. Where I'm now. Okay. So Of course, you've seen one of the aspects of those elements is that we can have integration within the enterprise applications, but one of the things which is very important is the user experience at the end of the day. In SAP, we have spent a lot of energy into a next generation user experience that we are calling Fiori. That means that all our user interfaces now follows the same principle and even the same technology stack. And one of those extensions is something that we are calling Copilot. That means that an SAP customer will be able to communicate with this SAP application, even talk to it, okay, through something which is called Copilot, all SAP applications, and they will know the context of this user. So they will know your preference, they will know your role, they will know your access rights. And this is why we have bought Recast.ai, because that allows us to integrate natural language processing and chatbots within that environment. And I think that perhaps if I have just 2 seconds, that's just a video of 1 minute.
Yeah.
Okay, which should start now, if I'm not, yeah, okay. And that will tell you a little bit what we mean by integration into the day-to-day. So this is SAP Hybris, Cloud for Customers, which is both Salesforce automation and marketing campaign optimization tools and all these kind of things. And normally it should, yeah, does it move? No, it doesn't move? Should I click on yes? Okay. Okay, no, okay, it doesn't move, so I have the same demo syndrome. But at the end of the day, what I wanted to show is that the sales manager will be able, for example, to sort all the leads that will become customers with a probability of becoming customers. But not only we provide this to the sales managers or the sales agents, but we can also provide them with a reason codes. So that means that we can, that's the same kind of technology which is used for credit scoring. When you refuse a credit to someone, you have to give them why you have refused exactly this credit for this particular individual. And that's the same thing that we are using, for example, in this integration. So the sales guys knows exactly why the score is high and why the score is low, so he can actionate directly around those kind of things. And we have zillions of workflows into enterprise applications now that will implement this technology.
Thanks a lot, Eric. So this time I give the opportunity to the audience. Otherwise, I start with questions. Okay, no questions. So I have one for you, Eric, which is talking about how to share knowledge and data input from different enterprise. So because on one thing, I'm a customer, I'm an enterprise, I want to protect my data, and the other thing also, I want to enrich maybe the machine learning output from other data that I could get from other enterprise. And here, there is a challenge here, which is how to do that, and at the same time, you want to be sure at your level that you're protecting the data from each customer to each other.
Yeah, well, I mean, the second point is that that's the easy point. So, I mean, we have zillions of technologies now in order to make sure that even if we're using the same machines for different customers, I mean, the data is completely siloed and that there is absolutely no bridge between all these kind of things. The other point is a little bit more interesting, which is the fact that even when I say that, for example, we are integrating predictive and machine learning within the business processes that are embedded into the enterprise applications, it's very likely that some customers would like to add external data to the one that we are mastering, for example, in SAP ecosystem. And for this, we have two kind of integrations that's a little bit close to the bring machine learning to the data or data to the machine learning at the end of the day. So we have what we call embedded scenarios where really, I mean, everything is in, for example, the operational systems or the sandboxing system, and in that case, only the data that is proprietary of the applications will be used. And we have also what we call side-by-side applications where, for example, we can go onto the cloud. And then after that, in the cloud, we can merge on mix some other data source onto that. But the thing is that at the end of the day, everything will be wrapped into something that we call predictive scenarios, and those predictive scenarios will appear as a single entity within the business processes. So we have ways of dealing with that. But that's an important stuff. I mean.
Okay. Any other question for Eric? Okay, thanks a lot. Thank you very much.